Today I will talk about what was absolutely missing from all of the previous lectures. It's the Vaadin Data Model. After this lecture you should have enough knowledge to build basically any kind of Vaadin application, maybe except things that are heavy on the client side, which will be the topic of the next lectures. At the beginning I will give you a brief description of how the data model looks. Then I will describe three key concepts and then show you some utilities that are built in the core framework. Then I will talk about components and layout that was missing from the overview a couple of lectures ago. Then we talk about buffering and validation. And at the end of the lecture I will present you the two containers, so two ways to connect to a database. So it will be a SQLContainer and very briefly JPAContainer. So let's start with the bigger picture of the Vaadin Data Model. So it all revolves around three central concepts. So it's a property, an item, and a container. The property is just a value and a type, the simplest possible thing. So a string can be a property because it has a value, it's the value of the string, and it has a type, it's a type string. Then we have item, which is a collection of properties, and then we have a container, which is a collection of items. So as I said, the item is a set of uniquely identified properties. So every property in the item has its identifier, most commonly referred to as a name of the property, and those have to be unique. So an item cannot have two different properties under the same identifier. And then we have container, which contains items that are similarly identified, so they have an ID through which we can access them. The key characteristics of Vaadin Data Model is that these are all interfaces. So there is interface property, there is interface item, and interface container. And the model itself doesn't contain any implementation. Of course, the framework contains reference implementation so that you can actually use the model. That also means that any component, any data component can use any implementation. So you can easily connect your own containers to existing components. The underlying data source is completely transparent. So the components, they operate on these three interfaces. They don't care what is the source of the data, whether it comes from a file or whether it comes from a database or whether it comes from somewhere else. Of course, there are events to these three key concepts. There is a built-in support, and this is done the Vaadin way. So by default there are no events, and you have to explicitly state that a particular property or item or container broadcasts events. There is type safety provided with the data model, so there is built-in support for validating user input. And then there are, at least to some extent, there are generics which allow you to nicely go around with the properties and their types in your code. And of course, since, as I said, these are all interfaces, this can be easily extended by just implementing the interface. Let's start with the property. As I said at the beginning, this is a typed value. So there is very little extra magic around that. So it's just a value and a type, and it's generic over the type of the value. We have built-in support for read-only status, so we can mark a property as read-only, meaning we will not be able to change the value it has. Of course, we can listen to changes in that status. The type of the property cannot be modified through an interface. Of course, your implementation may provide that, but the interface itself does not. You can use the information about the type of the property to typecast the value. And of course, the value itself is of that type, and there is support for events when the value is changed. So when one component in some place changes the value of the property, then all other components that might be interested in that, they can be notified. Extra interface new in Vaadin 7 is transactional property. So it provides support for buffering the value. So all the changes to the property are stored locally in the property itself until somebody calls commit, and then they are sent to the underlying data source. It is also possible to roll back the changes to the previous state, so the state of the previous commit. There is a similar concept in Vaadin 6 that is still around in Vaadin 7, but my guess is that transactional properties will be slowly taking over the Vaadin 6 concept. Okay, what property defines is also an interface called viewer. It is targeted for components that can show a value from a property. The interface does not specify that they are not allowed to change that value. So this is just for informational purposes. The generics are lost if we use that. And of course, that interface provides just two handy methods. So you can get property data source and set property data source. And the component is expected to update its value whenever you set new property data source. And of course, if the property broadcasts events, then the component should update its value when the value of the property changes. A similar interface is called editor, and this is for those components that are able to edit the value. It does not differ at all from the viewer interface. And the same concern, so this is just for informational purposes. So okay, once we have the property, we should organize it into some sort of a more concrete form. So we have items, which is each item is a set of uniquely identified properties. And what does that mean? So that means that we can get the identifiers or IDs of the properties that the item stores. So you can think of, for example, as property being a height of a person. So a height in itself being 2 meters, for example, is a property. It has a value, 2 meters, and it has a type, so it's a number. Whereas item would be a person that contains many such properties. So it can be height, it can be age, it can be date of birth, and so on. Item interface allows you to optionally add and remove properties. So you can do that. You can throw exception, of course, if you don't support that. And optionally, there is, of course, events for property set change notifier. So whenever we add or remove a property, we should broadcast property set change event. And there is no generics of properties at this point again, so all of that is lost. Similarly, as with property, we have viewer and editor. These are exactly the same interface. Well, editor extends viewer but does not add any functionality by itself. So it's viewing and writing contents of an item. There was just one component that was implementing this interface, so it was form, but it's deprecated in Vaadin 7, so you shouldn't use it. And I'm just mentioning it. And the two methods that we have is get item data source and set item data source, meaning that a component should update its state to whatever the contents of the item are. So it should get the property IDs and display them probably as some sort of fields with captions. Finally, the third element is the container. So we have a collection of items. So going back to this analogy of height and person, so this classroom, for example, can be considered a container. So each of you is uniquely identified, for example, by the place in which you are sitting. And then each of you has a number of properties, be it age, date of birth, and so on. What the container interface does is that it does not guarantee any item order. It does not allow duplicate identifiers. And the identifier can be any object. Typically, this is an integer number in databases at least, but you can use anything that works. It also places some constraints on the items it contains. So each item must have the same number of properties, and that have to be exactly the same properties in terms of type and the identifier. And of course, the identifiers of items, they have to be not null. So it has to be something that makes sense. Here is the overview of what the container provides. So we can operate on items and properties. So we can get for example, the size of the container, the IDs of all items that we have in the container, and that particular operation, this get item IDs, this can be time consuming and it is marked as such in the APIs. So you shouldn't call this method until it's really necessary. Then of course you can get the item based on its ID, and then you can check whether the container has an item of that given ID. And then optionally you can add or remove items, And there is item set change notifier associated with that. So whenever you add or remove items, then you should probably broadcast an event so that all the components and listeners, they are updated. A word here that changing a value of a property in an item is not item set change event. So whenever we simply change the values of properties in the items, we do not broadcast that. That event is reserved solely for adding, removing items to the container. The second thing we can operate on container is properties. So we can query them, so we can get a list of or collection of property IDs. So that is guaranteed that every item in the container will have those properties, exactly those properties. And then there is a shortcut method for getting a property of a particular item. So we don't have to get the item and then get the property. We can instead get just a property directly. And then of course we can get a type of property, and optionally we can add or remove new properties. And then again, a side note here, adding or removing properties to the container, if supported, should result in updating all the items it has. Container in itself, as I said earlier, does not guarantee much more than what was on the previous slide, but there is a bunch of interfaces that add certain or declare certain properties of a container. We go through them one by one and let's see how useful they are. So we start with viewer and editor. So these are components for viewing and writing contents to a container. Again, there is no difference, so the viewer editor can safely edit the container internally. It's just the meaning behind the interfaces that is different. All selects, so all the components that you can select data from, they are container viewers, and they present you the options to choose from. And there is a limited support to adding new items to some of them. And of course, all of them refresh when the underlying data source has changed. And then there are these two methods, one getter, one setter for the container. Similarly, the component that is implementing container viewer or container editor should update its contents when the container is changed and when it's explicitly set. So the first of, let's call it, utility interfaces is ordered. As I said, the container in itself does not guarantee any particular order of the items it stores, so they can be totally at random, and every time you call the get item IDs, then you can get a different order of these. What does ordered do is that it provides you the possibility to check what is the order of items. So you can check the first or last item, and then you can traverse them back and forth by next item ID and previous item ID. There is also optional support for inserting items after a particular one. The second utility interface is indexed. So this is ordered, but with some extra, just a non-negative integer index for each item. So this is something different than the identifier, which can be any object. So this is explicitly an integer, a non-negative number, and it might change for each item depending on whether we add new items or remove items from the container or set other options. We can, of course, get the ID by index, or we can get index of an ID, and then we can get a sublist or a subset of item IDs starting from one position and giving a number of many of those. As with the previous interface, we have inserting items at specific position, and this is something optional. So once we have ordered the container, we can also sort it. Sortable is an extension of ordered again, and it allows you to sort items. So that affects the order in which they are traversed. And if we have an indexed container that happens to be sorted, that also affects indices at which the items are available. There is just one method for sorting, so it takes an array of properties which we should sort by, and then the array of booleans indicating whether or not the corresponding property should be in ascending or descending order. This method, the method sort, returns no type, so it is explicitly stated that this is an in-place sorting. So you just sort the container itself, not get a copy of container that is sorted. The interface also specifies that not all the properties, they have to be sortable. So we can just return the array of those properties or those identifiers of properties that are sortable. And then again, there is optional support for adding items. And it's quite complicated and not well documented, and you shouldn't probably rely on that. So that if you add item after or at particular point, then it might change if you sort items in the meantime or after that. Okay, so now we have indexed, ordered, or sortable container. Now a completely separate branch of those utility interfaces is something that is filterable. So that reduces the items that are visible, all the get item IDs, that should return something that is filtered. So there is a support for built-in filters. The interface is named filter. And that's in-place filtering, which should broadcast events. So whenever we change filters or we add new filters, then we probably should broadcast the event that the set of items has just changed. Again, filtering affects order and indices, and it can be affected by sorting and so on and so on. And adding items is optional and it can be complicated. So for example, what happens if you add an item that doesn't pass current filters? So the documentation says that this item should be added, but it should be invisible and impossible to get back from the container until the filters have changed. Finally, the last interface is hierarchical. This gives you parent-child relationship between items. Typical example is a file system, of course, where you have directories which contain other directories or files. The major feature of that is that it's possible to have many root elements. So in typical trees, you have one root, whereas in here you can have many of them. So these are items that do not belong to any other item. There is explicit ability or disability to have sub-items. There is, of course, an optional support for moving items. You can reallocate them from one parent to another. And the documentation says that sorting, ordering, and indexing the hierarchical container is implementation specific. So if you happen to write a hierarchical container and you want it to be sorted or ordered, then you should explicitly document that. What is the particular behavior? So are you sorting first roots and then you sort children there, or what is the logic behind it? Okay, but these are all interfaces. They just basically tell you what to do, and they do not bring any functionality or anything that you could use. You can rely on them, of course, but there is very little use of practical use if you are doing programming. So if you are programming, then you want something concrete that you can build on. If you go to the property level, then we have object property, which is a straightforward or reference implementation of the property interface that broadcasts all events. And it is, of course, generic over a type. If you are building a custom item or a custom container, then there is no need for you to implement property interface. Usually, you can just safely use object property. Of course, you can get the value of a property from an object with methods. So there is a class for that as well. It's called method property, and it binds the property to a setter and getter of an object. This is very useful with Java beans, or basically any object and any method that you just define in the constructor. In the basic form, the constructor takes 4 parameters, so it's a type of the property, the instance of the object to get the property from, and the setter and getter methods for that. They can be either methods that you get from reflection, or they can be just names of the methods with strings. And there is a bunch of other constructors that support getting the properties from parameters, and I just refer you to documentation if you are interested. We can also have a property if we have a string property that is bound to a file in a file system. So there is text file property that does just that. So it is connected with a file. It supports events, so whenever we change the property value in the program, then it will broadcast event. Of course, if we change the file, then it will not fire an event because the property will not know that the contents have changed. Of course, it writes to a file and reads from a file, and the constructor is really straightforward. And if you haven't found anything that you would like to use in the previous property implementations, then there is abstract property, which just handles listeners and defines methods for firing events and does nothing else. So it doesn't even fire the event, so you have to do that yourself, but there is a stub for that. Let's move on to items. So probably the most commonly used item is a bean item. So it makes any class that has setters and getters an item, so fitting our data model. And it's generic over bean type. So if we call a method getBean, we will get exactly the underlying class without any casting. And we can construct the bean item with all the properties by just passing the class there, or the object there in the constructor, or we can limit bean item to a subset of certain properties, so by just providing this subset. So once we have the bean items, then we should probably store them in some container. So yes, there is a class for that. It's called bean item container. It's generic over the same bean type as the bean item. It's an in-memory container, so it doesn't save the data anywhere. So once you exit your application, then all the data that you have made, or the changes you have made to your data, are lost and you have to recreate them. As I said, it uses bean items, and it uses bean items as the identifiers. So when you get the item IDs, you are actually getting a list of the objects that you have in the container. Bean item container is a really useful class. It contains almost all interfaces you could think of. So it's filterable, indexed, ordered, and it's even sortable. And on top of that, it broadcasts events when you add items or remove items. But it does not support adding or removing properties. Well, you probably figured that out. If you have a class, then it's not that easy to add new features to it. So that's why there is no support for that in bean item container. Slightly twisted version of bean item container is something called bean container. It is different in the aspect that it uses some IDs for beans, so not the beans themselves. That means that you need to provide some ID to bean resolver, so something that will get you the ID if you give it a bean, and the other way around, so it will give you the bean once you give it the ID. Again, this is filterable, indexed, ordered, and sortable, and broadcasts events, and does not support adding or removing properties. I said previously an analogy with hierarchical container that file system is a good analogy. Of course, there is a class for that. It's called file system container. It gives you hierarchical container, just hierarchical, so no sorting, no ordering, no indexing, and no filtering over the server file system. So it's not something that the user has in the browser, but something that there is on the server. It's optionally recursive, so you can just restrict to the files that are in the root directory, or you can just recurse. And there is even optional filtering of file names. So it's not a container filter, it's a file name filter that just, for example, lists all PDF files that you have on your local system. There is a fixed set of properties, so you cannot extend that, you cannot remove those properties, and it's guaranteed that every file item will have an icon, which will be a resource that can be empty. It has a last modified date, it has a name, and the size of the file. If you want to build some in-memory container on your own, then you can extend the class called abstract in-memory container, which is generic over three things. So it's the identifier of the item, property identifier, and the base item class. It is indexed and ordered, so it allows you to get the order of your items. There is partial support for sorting and filtering, but it's just that the methods are there. It's not the interfaces that are declared. So you can, if you want, you can just implement the missing methods and declare interfaces, and there you go, your container will be sortable and filterable. If not, well, then you just ignore it. And of course, it broadcasts the item set change events whenever you add or remove things. Then there are wrappers. So if you have a container already and your container is missing a feature that you would like to have or you require in your application, so you can use wrappers, and then they are supposed to provide you that missing functionality. So there is container hierarchical wrapper, which gives you a hierarchy of items, and there is container ordered wrapper, which gives you an order of items to your container. And then there is hierarchical container ordered wrapper, which adds order to hierarchy if you already have one. Fortunately, there are no other monsters like hierarchical container ordered wrapper, because memorizing all these names would be problematic. So why I'm mentioning the wrappers is that they are pretty much always confusing, as some components, they use wrappers internally. So when you set container data source, then if you get the container data source, it can be something completely different because it has been internally wrapped to fit the needs of the component. The component that displays items in a tree is an example. So if you pass a container that is not hierarchical, then what you will get is actually the container hierarchical wrapper, not your container. So the solution to that is always, of course, implement as much as it's possible. Finally, we have a reference implementation called JPAContainer, which is everything but not hierarchical. So it broadcasts all events. It's an in-memory container. It takes any item ID, any object as item ID, any object as property ID, and any item in it. And of course, there is a hierarchical container, which does the same thing as indexed container, but with a hierarchy. In general, if you want an in-memory container, then you shouldn't implement your own things unless you really know why you are doing it. The situation, of course, changes if you have to connect to some external data source which is not supported by Vaadin.